Students, in this video we are going to discuss group 17 elements, atomic, physical and chemical properties. The member of this group are fluorine, chlorine, bromine, iodine, astatine, tennessine. Now this group is also called halogen, halo salt. Okay, so these are salt forming compounds. So first we'll discuss occurrence of these. Now fluorine and chlorine are fairly abundant, so while bromine and iodine are less abundant. Fluorine is present in mainly in insoluble fluorides like fluorspar, calcium fluoride, cryolanite having formula Na3AlF6, etc. Now small quantities are also present in soil, river water, bones, teeth of animal, etc. Okay. Now seawater contain your chloride, bromide, iodide of your sodium, potassium, magnesium, calcium, but sodium chloride, okay, sodium chloride is in abundant, like mainly it contains sodium chloride, so of 2.5 percentage by mass. Now dried deposit of dried up seas contain compound sodium chloride, cryolanite, and marine life contain iodine, okay, etc. in their system. Where seawood, for example, it contain up to 0.5% of iodine, and chili, saltpeter, okay, it contain up to 0.2% of sodium iodate. So now this is your radioactive element astatine. We are going to discuss atomic property, where first we'll discuss electronic configuration. Okay, now the members are fluorine, chlorine, bromine, iodine, astatine, tennessine, right? Now the electronic configuration. So this is in period 2, right? So what is its valence electronic configuration? It is your 2s2 2p5. Then chlorine, period 3, so 3s2 3p5. Bromine, so it is in period 4, so 4 देखि d block element start हुन्छ, so 3d10, right? Then 4s2 4p5. Then iodine कुन चाहिँ period मा छ, 5th period, so 5s2 5p5 and 4d10, okay. And astatine, it is in 6th period, so 6th period देखि now f block start हुन्छ, so 4f14 हैन, then 5d10, so 6 मा छ, so 6s2 6p5. and tennessine कति हुन्छ, 5f14 हैन, 5, then 6d10, त्यहाँदेखि 7 period, so 7s2 7p5. Now what would be its complete electronic configuration? So fluorine को अगाडि के छ, helium, so He 2s2 2p5 is your fluorine को electronic configuration. Okay, now chlorine को के छ अगाडि, neon, so Ne 3s2 3p5 complete electronic configuration of chlorine. Bromine को then Ar 3d10 4s2 4p5. then iodine को argon krypton, right, 4d10 5s2 5p5. then astatine को xenon 4f14 5d10 6s2 6p5. then tennessine को radon, right, then 5f14, then 16 3d10, then 7s2 7p5. Okay, so these are the electronic configuration. Now what is common in them? 2s2 2p5, 3s2 3p5. so that is means, what is the general electronic configuration for group 17 element? It is ns2 np5. Now next, atomic size and ionic size. Now this group 17, okay, it will have the smallest atomic size, smallest size. Why? Because of your large nuclear charge, isn't it? Now what will happen to the atomic ionic size on moving down the group? It increases, right? Down the group atomic size के हुन्छ, increase हुन्छ, atomic or ionic size increase हुन्छ. Why? Because of your addition of quantum cell or your extra valence shell. The next is your ionization enthalpy, हैन? So it have the smallest size. So that means what about the ionization enthalpy? It will have the high ionization enthalpy. Ionization. Now what will happen to the ionization enthalpy on moving down the group? What will happen? Ionization enthalpy will decrease. Why? Because your atomic size will increase. So because of that, what happens is it become easier to remove valence electron, isn't it? So your ionization enthalpy decreases down the group because of increase in the atomic size. Now next is electron gain enthalpy. Okay, now what will happen to the electron gain enthalpy? Again, okay, group 17 have most negative electron gain enthalpy. Okay, so why? Because of its electronic configuration. What is its electronic configuration? ns2 np5. So that means after gaining one electron, it will acquire electronic configuration ns2 and np6, which is the configuration of noble gas, right? Stable configuration. So for that reason, it easily accept one electron and will acquire the configuration. That means it will have most negative, okay, electron gain enthalpy. Now what will happen to the electron gain enthalpy below down the group? के हुनुपर्छ electron gain enthalpy, so it decreases, right? So it decreases in the order, or it becomes less and less negative on moving down the group. So so that means chlorine, bromine, iodine, right? So this one will have the least negative electron gain enthalpy. But if you compare the electron gain enthalpy of fluorine and chlorine, okay, now according to its size, so fluorine must have a yes, more negative electron gain enthalpy, but chlorine, okay, fluorine have less negative electron gain enthalpy than chlorine. Okay, now the question is why? Now the reason is very simple, as we have already discussed for the electron gain enthalpy of oxygen and sulfur. Okay, the reason is same. So के हुन्छ भन्दाखेरि यहाँ तिम्रो fluorine, right? It is in period 2. Okay, because of that, so it have compact size, right? It have the smallest size. So that means in small space, so your electrons are crowded. So that means it will experience what? More inter-electronic repulsion. Okay, sir. So तिम्रो fluorine मा, so inter-electronic repulsion is more than that in chlorine, where the size of chlorine is comparatively larger than that of fluorine. Now because of this inter-electronic repulsion, okay, the incoming electron will experience more repulsion in fluorine than the chlorine. That means your incoming electron will not easily accepted in fluorine compared to that of chlorine, which means your fluorine will have less negative electron gain enthalpy than chlorine. Okay, the reason is very simple. Because of the compact size of your fluorine, it will have more inter-electronic repulsion than chlorine. Because of that, the ace with which this fluorine accept electron, new electron, is lesser than that of chlorine. Now next is electronegativity. Now electronegativity, fluorine is the most electronegative one, and down the group the electronegativity decreases in the order FCl Br I. Okay, why? Because of increase in the atomic size. So next we are going to discuss is physical properties. So first, physical state. Fluorine, chlorine, gas, bromine, liquid, and iodine, it is solid in state. Next is melting point and boiling point. Now on moving down the group, what will happen to the atomic size? It increases, right? Now the interaction which is there in this fluorine, chlorine, bromine is your van der Waals interaction. Okay. Now, so again, what will happen to the size? It increases down the group, right? भनेपछि fluorine, chlorine, bromine, iodine, right? Now, because of the increase in the atomic size, your magnitude, okay? Magnitude of van der Waals interaction will also increase in the same order. So because of that, melting point, boiling point of these will increases in the order I2. Okay, so iodine have highest melting point, boiling point. Why? Because it have the largest size, and at the same time the magnitude of van der Waals force is maximum in iodine. Next is your halogen. Okay, so they are colored like fluorine yellow in color, chlorine greenish yellow, bromine red brown in color, and iodine is violet solid. Okay, now that means your halogen exhibit color. Now, what is the reason for color of this compound or color of this halogen? The reason is simple. This halogen, okay, absorbs energy from visible region. Visible means colored, right? And your and after this, so your valence electron will get excited to the higher energy level. Because of this, your halogen, okay, are colored in nature. Again, why? Because of absorption of visible radiation from visible region, which lead to the excitation of valence electron to the higher energy level. So next, solubility. Fluorine and chlorine, okay, they react with water, but bromine, iodine, they are strongly soluble in water, okay, but they are soluble in various organic solvents like carbon tetrachloride, chloroform, carbon disulfide, hydrocarbons, etc. Now next, enthalpy of dissociation of this molecules, okay, chlorine, bromine, iodine, uh, fluorine, iodine. Now chlorine will have the highest bond dissociation enthalpy, 242.6. Okay, the next is your bromine 192.8, fluorine 158.8, iodine 151.1 kilojoule mole inverse. Now, what is the reason that this fluorine is having low bond dissociation enthalpy compared to these two? So, as we have already discussed that fluorine, okay, have the smallest size, right? Because of the smallest size, okay, now because of the smallest size, so there is more electron repulsion of this lone pair, okay, which make this bond make this bond weaker, okay, because again because of the smallest size of this fluorine, so there will be more interelectronic repulsion of this lone pair, making the bond weaker, whereas chlorine, okay, because of comparatively large size than this fluorine, okay, so the repulsion is very weak. The repulsion is less here, so that means it will have the highest bond dissociation enthalpy. On moving down the group, the bond dissociation enthalpy decreases. Why? Because your length, again the atomic size increases, your bond length increases. So bond length increases means what? The bond dissociation enthalpy decreases. Here question arise like why fluorine, okay, though it is the first member, right, among the family, so why it have the least bond dissociation enthalpy compared to that of chlorine bromine? The reason is because of its smallest size and high interelectronic repulsion of the lone pairs. Now we'll move to the chemical properties of group 17 elements. First, oxidation state. So they exhibit various oxidation state like -1, +1, +3, +5, +7. But fluorine show only -1 oxidation state. Why? Very simple reason. This is the most electronegative one, right? Most electronegative, and it do not have vacant d orbitals, absence of your d orbitals, okay. So because of this reason, okay, it will have only show -1 oxidation state. Fluorine, okay, will not show any positive oxidation state. Why? Because it is the most electronegative element. Now chlorine, bromine, iodine show oxidation state -1. They also show +1, +3, +5, +7 oxidation state. Now, high oxidation state of chlorine, bromine and iodine is shown, okay, in interhalogen compound. कहाँ चाहिँ हुन्छ भन्दाखेरि interhalogen compound मा हुन्छ, then oxides मा हुन्छ, then oxo acids मा, okay. So this chlorine, bromine and iodine show the maximum or high oxidation state. Just say interhalogen IF7, so where the oxidation state is +7, Cl2O7, where the oxidation state of chlorine is again 7. So these are the examples. Now, as we have already discussed that your halogen exhibit highest oxidation state in your oxides or fluoride okay, so oxygen and fluorine both stabilize higher oxidation state of metal, but oxygen exceeds fluorine in doing so. That means your halogen show highest oxidation state in oxides. Okay, now the reason. So though oxygen, fluorine, okay, though both have smallest size दुई जना कोई, then they have high electronegativity, right? But oxygen have unique property to form p pi multiple bond. Okay, now because of this reason, higher oxidation state लाई stabilize गरिदिन्छ p pi multiple bond, and because of that your halogen will have highest oxidation state in oxide. Now next, oxidizing character of this halogen. So this halogen, okay, they are most oxidizing in nature. Why? Because they have because the electronegative electron gain enthalpy of these element are more negative, so they easily accept one electron. So because of that, so they are strong oxidizing in nature. Now your oxidizing character depends on three parameters. So one is bond dissociation enthalpy, okay. Another one is electron gain enthalpy, and third one, okay, is hydration enthalpy. Now among your halogen, okay, the most oxidizing nature, okay, most oxidizing in character is fluorine. Why? Because of its, we know that bond dissociation enthalpy, though it have low bond dissociation enthalpy compared to that of chlorine, right? Even though this is strong oxidizing agent. Why? Low bond dissociation enthalpy. Now again we know that it have low, right, less negative electron gain enthalpy compared to that of chlorine, right? But it have high hydration enthalpy. So because of this, okay, fluorine is the most oxidizing in nature. Now the oxidizing character, okay, it decreases down the group. So fluorine is the most oxidizing in nature, right? Then chlorine, then bromine, then iodine, because down the group what happen is electron gain enthalpy, it will become lesser and lesser negative, and your bond dissociation enthalpy also decreases down the group. So because of this reason, okay, your oxidizing character decreases down the group, and among your halogen, fluorine is the most oxidizing in nature. Now the highest oxidizing nature of fluorine is shown by this example. Okay, fluorine when reacts with water, okay, so it will oxidize water to oxygen. So whereas how the other reacting like chlorine, bromine, so in water, okay, it is forming haloacids and your oxo acid. So whereas iodine, so it is non-reactive in water, but your iodide in acidic medium, okay, your oxygen will oxidize it to iodine and water. So as we have already discussed the anomalous behavior of group 2 period 2 elements, right? They show anomalous behavior. Why? Because of four reasons. के थियो? Small size, right? Smallest size, then high ionization enthalpy, right? Ionization enthalpy, then more high electronegativity, and spelling well, and high electronegativity, and your absence of d orbital. So these are the 4 regions because of which your period 2 elements show anomalous behavior. Now let us see what are the anomalous behavior that fluorine show among the group. Now most of your fluorine, okay, compounds, they are exothermic. The reaction of fluorine, okay, are exothermic because your compound, okay, with fluorine. So these have small and very strong bond. The compound have small and very strong bond. So because of that, okay, the reaction with fluorine and most of the reaction of fluorine is exothermic in nature. Now this fluorine forms only one oxo acid. Why? Because this is highly electronegative, right? So one is it is most electronegative, and other reason is absence of d orbital. Whereas other member of group 17 show form number of oxo acids as they contain d orbitals, right? Now next is HF is liquid, whereas hydride of this group 17 element all are gaseous, right? What is the reason? The reason is very simple. So HF being highly electronegative, right, and having smallest size, so it can form intermolecular hydrogen bonding. Okay, so this is your intermolecular hydrogen bonding. So this reason makes your HF in liquid state. Next is reactivity towards hydrogen. Formula very simple, HX, where X is your F, Cl, Br, I, right? And your affinity, okay, for this hydrogen decreases from fluorine to iodine. Why? Because the atomic size increases. Now next is the acidic strength. Now acidic strength of this hydride, okay, increases in the order HF, then HCl, HBr. So Hi is the strong acid. Why? The reason is very simple. What will happen? Atomic size, right, of central of this halogen increases in the order F, Cl, Br, then Hi, Br and I. Then what will happen? Your bond length, what will happen to the bond length because of the increased size? Yes, it increases again in the order HF, HCl, HBr and Hi. Then what about your bond dissociation enthalpy? Bond dissociation enthalpy, it decreases, right, in the order HF, it also increases, it decreases Cl, HBr, then Hi. Okay, so it means you're on moving down the group from HF to Hi, the ace with which your H plus ion releases increases, right, because of low bond dissociation enthalpy and increase in the bond length. So that means Hi will release, the ace with which Hi release H plus ion is more compared to the rest. So because of that your acidic strength of Hi is the maximum and acidic strength of HF is least, as because it will have the highest bond dissociation enthalpy. Now next, stability. Now again stability, so it depends on the bond dissociation enthalpy, right? So stability is directly proportional to bond dissociation enthalpy, isn't it? So more the bond dissociation enthalpy, more will be its stability. So that means your stability decreases down the group HF, then Hi, HBr and Hi. Okay, HF, HCl, HBr and Hi, it decreases down the group because of decrease in the bond dissociation enthalpy. Now next is the reducing character. Okay, now reducing character is also dependent on stability. How? So it is inversely proportional to the stability, right? Reducing character is inversely proportional to the stability. That means more stability means less reducing character, less stability means more reducing character. So the order for stability was this, like HF, you know, more stable थियो than HI least stable. So that means reducing character of HF will be least and HI will be maximum. Halogen, okay, so they form compound, many oxide with oxygen, but most of them are unstable. Just like fluorine le form garcha OF2 oxide, OF2 and O2F2. However, OF2 mate ke cha thermally stable, okay, at 298 Kelvin. Now instead of, they are not called like a compound of oxygen and fluorine, okay, it's not oxide, it is not called as oxide, rather it is called as oxygen fluoride. Why? Because if you compare the electronegativity of fluorine and chlorine, fluorine is more electronegative, okay, than oxygen. So because of this reason, हामीले compound of oxygen and fluorine, it is called oxygen fluoride, not fluorine oxide. This O2F2, okay, O2OF2 and O2F2 both are fluorinating agent. That means they give fluorine to the other element, right? But your O2F2, okay, it oxidizes plutonium, okay, to plutonium hexafluoride, and this reaction is used to remove plutonium as PuF6 from spent nuclear fuel. It is used to remove this plutonium. Now next is your stability of oxides. Your your chlorine, bromine, iodine, okay, they form the oxidation oxides where the oxidation number can be your +1 देखि लिएर +7 सम्म हुन्छ. But and stability of this oxide, okay, decreases in this order, I minus Cl then Br. Br को के हुन्छ, oxide will be the least stable. अब iodine को why the stability of oxide of iodine is maximum भन्दाखेरि, because iodine have maximum polarizing, greater polarizability, okay, of bond. भनेपछि जुन पनि bond हुन्छ, okay, I ले के गर्छ, polarize गरिदिन्छ, and because of that the bond become more covalent and more stable. Okay, next is your chlorine, okay, so chlorine को oxide, why this is stable भन्दाखेरि, okay, now chlorine र oxygen, so they can form multiple bond. यिनीहरूले के गर्नु सक्छ, multiple p pi d pi bond form गर्नु सक्छ. So because of this reason, this chlorine, oxide of chlorine is stable. Now bromine is the least stable. किन न यसको polarizability हैन effect उयो छ, बेसी छ, न it will form your p pi d pi multiple bond form गर्दैन with oxygen, and because of that your oxide of bromine, okay, it is less stable compared to the oxide of your iodine and chlorine. Now chlorine को oxides are some examples, just say dichlorine monoxide, then chlorine dioxide, chlorine dichlorine hexaoxide, dichlorine heptaoxide. So these are the oxide of chlorine, okay, and they are a highly reactive oxidizing agent and they tend to explode. र यहाँ ClO2, okay, is used as bleaching. यसलाई के गर्छ, ब्लिचिङ एजेन्ट युज गर्छ, and it is used to bleach paper, pulp, textile in, and also used in water treatment. Right? Next bromine oxide, so it form oxide of formula Br2O, dibromine monoxide, bromine dioxide, bromine trioxide, and these are least stable, okay, and they exist at a low temperature and they are very powerful oxidizing agent. Next is your iodine oxide, है ना, of formula I2O4, I2O5, I2O7. They are insoluble solid and they decompose on heating, okay, and I2O5 is strong oxidizing, very good oxidizing agent, and is used in estimation of carbon monoxide. Now next is reactivity towards metal. Your halogen reacts with metal to form salt, metal halide, right, of formula MX. So M is your metal, just as sodium and halogen, right, chlorine. यसले के दिन्छ, sodium chloride, magnesium, and bromine, what it give? Magnesium, magnesium bromide. भयो. Now the ionic character of halite, okay, decreases in the order MF, MCl, Br, MBr, Mi. Now तिम्रो के हुन्छ भन्दाखेरि, so on moving down the group like fluoride, right, then chloride, what will happen to the ionic size? It become bigger and bigger. Okay, now तिम्रो जुन चाहिँ नेगेटिभ साइज जति ठुलो भयो, cationic size जति सानो भयो. Okay, now according to Fission's rule, the polarizing effect of your bigger anion, okay, will be more compared to the smaller anion. So यसले more polarize गरिदिन्छ, okay, this cation लाई. Now because of that, okay, the bond become now more polar, bond become more covalent. So what does it mean? Covalent, more covalent हुनुको मतलब के हो? Less ionic हुनु हो. So okay, and the ionic character of halite के हुँदै जान्छ? Decrease हुँदै जान्छ down the group. Why? Because of the increase in the polarizing effect of the anion because of its increase in the size. And again, your halide in higher oxidation state is more covalent, so because of the same reason. जस्तै यहाँ tin chloride, okay, tetrachloride, then lead को tetrachloride, antimony, pentachloride, uranium hexafluoride, okay, these are more covalent than your SnCl2, PbCl2, SbCl3, UF4. Why? Because here the oxidation state, if you compare the oxidation state, you know, it's more हुन्छ. ठीक है sir? Then the last is your reactivity of halogen towards other halogen. Now your halogen combine with member, you know, amongst themselves, and they form different compound. त्यसलाई के भन्छ? Interhalogen compound of your halogen, different halogen. अनि तिनीहरूको फर्मुला, interhalogen को फर्मुला हुन सक्छ XX dash, XX3 dash, XX dash 5, XX dash 7, जस्तै CLF भइहाल्यो यो फर्मुला हैन. यहाँ CLF3 भनिदिउँ. This is your Br F5 and this is your IF7. Okay, so these are your interhalogen compound of halogen and halogen. So this we again study in detail in next video. Thank you all.